Good morning, good afternoon, and good evening. Welcome everyone to our next Cloud Launch and Learn session today. We have a special guest speaker, Christina from Norway. Hi, Christina. How are you doing?
Hello everyone. I'm doing great. I'm doing good. How are you?
Doing well, thank you. So we had a little bit chit chat before the session, and as you know, Christina is a Microsoft MVP, and she is also CNCF ambassador. So she knows a lot about containerizations and Kubernetes, and you can ask her a lot of questions during the session. So, you have 1 hour, I would say Q&A, so to speak,
Ooh.
but I'm not pushing too hard on her. Okay, so if there's something you don't get responses during the session, you can always contact her back on social channels, and I'm pretty sure she would be happy to guide you. In addition to that, as you know, today we are going to speak about a managed Kubernetes service and how you can get actually prepared for that. Because before running to the Kubernetes and setting it up and having this hype of, we are going to have everything in containers, you need to make a pre-planning, and Christine is going to help us to know what are those day zero preparations that we need to do. In addition to that, I want to mention that Christine is from Norway, Oslo. She's joining as one of the few very qualified people that I had, chance to speak with in terms of containerizations and Kubernetes. And she's prepared this, presentation for all of us. So without any overdue, I want to give it back to Christina, the studio, and so that she can put her magic on.
Thank you so much, Elhan, for the kind introduction of myself. Yeah, then I think we can kick it off.
Mm-hmm.
I see that you can see my screen, so that's great. All right, so let's kick it off. Since Elhan presented already a few words about me, I will not go much more into detail. One other thing I wanted to mention, I am doing a bunch of different things for in the tech community because I find it very giving and fun. And one of the things, a part of being ambassador and MVP, is that I am also a co-host of the Kubernetes Unpacked podcast together with Michael Levan. So if you would like to kind of have one more resource where you would like to hear about different topics around cloud native and Kubernetes ecosystem, you can also check that out. Or as Elhan said, I'll be very happy to chat with you also after this presentation. So don't hesitate to reach out to me. So let's kick it off and talk more about managed Kubernetes service and day zero. And I have been in a project where we have also failed with production setting of the workloads on a managed Kubernetes service to production. And had we didn't fail after it was in production, but we realized that there was much more that needed to be done. So we had to roll back and take additional time and figure out how we're going to approach it to fully make our platform production ready. And I have also been through these last years talking to other teams in other companies who have also seen and experienced challenges with managed Kubernetes service. And there are some facts out there that may give you a false impression of that you don't have as much responsibility as you think you have in terms of operating those Kubernetes clusters and making them production ready. So with this session today, I hope that I can raise awareness for some of the domains which I together with other teams have found important to think about and plan for as part of the day zero stage of adopting Kubernetes and managed Kubernetes service like AKS or GKE or EKS. And there are a few questions out there that you may be thinking about when you think about managed Kubernetes service, for instance. Isn't that easy just because it is a managed service? Doesn't that mean that the cloud service provider is responsible for managing those Kubernetes clusters for me, and I just need to focus on getting my applications up and running there on that cluster? And isn't that just enough for me to write some YAML to deploy my applications and then it's ready to go for production? And if that's only me who took enough tutorials, who got some experience working with Kubernetes, and I find myself proficient, so isn't that enough for me and my company to get my applications out there on Kubernetes, on managed Kubernetes service and out in production? Or if there is an operations team, isn't that their responsibility to just take it over straight away? Shouldn't that be easy enough? Well, answering to all those questions, the short answer is no. And there are some misconceptions around that. And we have, in one of the projects where I was working in, we also had some of these assumptions. And as we were adopting it at a later stage, we had to use additional time to kind of get back and rework a few things. And that's why I hope that I can help you to avoid doing that when you get back to your customers or get back to your own project and start looking into adopting a managed Kubernetes service. So the hard fact is that even though it's called managed, in most of the cases, managed Kubernetes service is not platform as a service offering. I have been working a lot with AKS, and which is Azure Kubernetes Service, which is a managed Kubernetes service offering from Microsoft. And for example, if you check their documentation, they stated straight away, loud and clear, that AKS is not platform as a service offering. So even though cloud service providers manage control plane, which is kind of the back end of the Kubernetes clusters, you still have responsibility to manage, secure, properly configure, operate, and upgrade the worker nodes where your applications will be running in Kubernetes. And this is not a matter of a few clicks. And if we think about cloud, we hear a lot about shared responsibility model, and it applies in this case as well. There is a big extent of responsibility that cloud provider has, for instance, for the control plane and for the infrastructure that Kubernetes is running on. But we as consumers also have a responsibility not only for preparing our applications, but also for managing and operating kind of the consumer part of those Kubernetes clusters. And there are many discussions out there and many memes related to Kubernetes being hard. And I think it's worth bringing up that question here as well. And I would say that the Kubernetes in itself is not necessarily hard, but it requires patience and it requires work and continuous learning to kind of fully grasp and fully get hands-on with Kubernetes and understand fully its ecosystem. And Rome wasn't built in a day. There is a saying that says that, but they were laying bricks every hour. And I think that's a really good saying in this case as well, because that means that with this session as well, I would like to kind of help you get that overall picture and understanding of what it takes to start working with managed Kubernetes service. And by getting that picture and by figuring out that step-by-step approach as part of the day zero phase, your adoption process may be less painful. And the layered approach in this case is the key. So you will not necessarily manage to harden it all, fix it all straight away from day one. You may need to start small and expand and prioritize. So if we get more concrete, if we get to look at some of the different domains that are worth thinking about as part of the day zero phase, I think the first one and the most important one where you would start is evaluating the readiness of your applications. And there are some great success stories and some great use cases that you can quickly search upon when you are looking for information, when there is a good use case for adopting or for going ahead with Kubernetes. And some of the stories that I want to bring up, for example, is one success story that where Forza Horizon, which is a racing car game, they managed to migrate their .NET Framework applications, .NET Framework microservices to a managed Kubernetes service, which was AKS, and they were able to scale to from hundreds, I think from 300,000 to 3 million users playing the game simultaneously. And that's quite a cool story. If you haven't checked it out, I would recommend you to do that, because it's like very interesting how they were thinking in terms of that migration. But once you start looking into the architecture of their application, into how they did this transition, you may see that they had 17 pretty lightweight microservices. And even though they were running on .NET Framework, they managed to utilize Windows containers, which were pretty lightweight, and therefore it was relatively straightforward for them to also scale and upgrade those containers, compared to if that was a larger monolithic application, which often is being brought up as a potentially good use case for migrating to Kubernetes. Another story is related to the News UK, which also had a legacy Java application for user authentication and access control, and they also migrated that to the managed Kubernetes service from Amazon. And in that case, also, once you start reading how they did that, you may also see that their application was pretty lightweight, and it made it therefore possible for them to get it out to containers deployed on Kubernetes and achieve that possibility for self-healing and fast scaling that they really needed, both in terms of scaling out and scaling down when there was lesser load. So it does not mean that lift and shift to Kubernetes will fix all of your problems, or you will get that fast, easy scaling out of the box. You will need to evaluate if your applications are actually ready, if they are implemented with cloud native principles in mind, how heavy they are, how much warm-up time your applications require in order to get up and running. And I think it's worth mentioning, because this is something we also learned, and I also learned with time, is when you are containerizing applications, it's important to think about the overall image size. And if you have microservices, if you already have a distributed system, typically it's easier already. You kind of have them already as lightweight applications. But in some cases, you will be looking into ways of breaking up that monolith and creating separate services. And that's when you need to think also about the container image size, because it consists of a few pieces. It consists of the base image, that includes, for instance, a necessary framework that your application requires to run on, like .NET or Java. And then on top of that, you also have security patches and updates that are continuously being added to the base image. And then you have the size of your application itself. And for example, there was one case where we had a base image for ASP.NET Framework 4.8, which was 5 to 6 gigabyte in size. And then updates and patches on top of that ended up being 3 to 4 gigs in size. And then the application itself was a few gigs. And then you suddenly have a container image that is in size of 10, 11 gigs. And that has consequences. That has consequences in terms of how much time it takes to pull that image on every node in Kubernetes if it doesn't exist from before. And also, if you have warm-up time on top of that, where you need to run specific operations before the application is up and running and ready to receive requests, then that scalability may become pretty challenging. So you will need to evaluate in what state your applications are and if they are actually ready to be and mature enough to be containerized and deployed in Kubernetes. And apart from that, it's worth thinking about the overall technical roadmap that you have in your own project, or if you're a consultant and will be talking to clients, what are the strategies? Would you like to run on a single cloud, or do you have a multi-cloud strategy? Because this may affect the choice of the tools that you may need as part of building this platform. Will you only be running applications in cloud, or will you have a hybrid setup where you may have some workloads running on premises? And maybe in some cases, Kubernetes may be an overkill, like you see on the picture here. In some cases where you have a few microservices that require extreme scaling, or you would like to run, for instance, machine learning processes in Kubernetes, this can be a really good candidate. But you may have a blog, a pretty lightweight blog, and rolling out a full-fledged Kubernetes cluster for that just to deploy it may be an overkill. And there are some options out there, the serverless options that you can utilize, where kind of the complexity of also managing and operating the worker nodes, the consumer part of the Kubernetes cluster, is also abstracted away from you. So like you have Azure Container Apps in Microsoft, in Azure, and then EKS, Fargate, or GKE Autopilot, for instance. So those are serverless serverless offerings where it's more of a black box, and you can just focus on deploying your applications as containers in, for instance, this serverless offering, but the whole cluster is managed for you. So you just focus on configuring what's needed properly for that application to run on the cluster. And if you have a use case where you don't need that many customizations, or you don't need, for instance, to use custom resource definitions, or you have more or less standard setup, in that case, that may be more than enough for your use case. So this is totally worth evaluating as part of the day zero phase. And another important point that I also like to talk a lot about is the organization readiness, because in most of the cases, that will not only be you working in your project, both with Kubernetes and also in terms of adopting it and changing the routines and potentially building a platform that is needed in order to run your applications at scale in production on those Kubernetes clusters. And that's where it's important to ensure that the organization, the teams are also ready, and you are ready to avoid being a single person taking responsibility for it all. And there is there was a bit of a buzz in the social media, and I think it's still ongoing here and there, where people talk about the fact that you don't need Kubernetes. And this is not the session where I would say, no, you don't need Kubernetes, so thank you for your time. No, this is not to scare you, but this is just to raise that awareness, to give you to make it easier for you to make informed choices when you get back after the session and will need to evaluate your options and what would be the most optimal decision for you as well. Even though there are many companies and organizations that are working with Kubernetes and have successfully adopted it, it is really powerful, and it is very cool to see how fast it evolved and how widely it's adopted. But focusing or making that choice of adopting Kubernetes just because someone like Spotify or Mercedes-Benz succeeded with it and are talking about it and showing this awesome technology, just using that as a single reason for, and the most important reason for adopting Kubernetes and managed Kubernetes service is something I would totally not recommend doing, because there are so many different use cases and so many factors involved, and you would need nevertheless to perform that evaluation yourself in your own project. And adopting Kubernetes will require making cultural shifts as well. So you would need to consider if this will bring value to you, if this will bring value to your customers, why, or to your users. So why are you doing this is the essential point of the day zero phase. You need to think about how those Kubernetes clusters will look like in your specific use case prior to implementing it, and how many resources will need to be involved into it. And with managed Kubernetes service having, from my experience at least, having a single person, maybe if you have a single Kubernetes cluster, maybe that will be possible. But I think that, and from my experience, that would be pretty challenging. So you would need to have multiple people involved, multiple stakeholders. And that's why it is important to have that alignment early on. So in one of the projects, we had not only a cloud offering for our application, but we also had an on-premises customer base where we have been offering the same product just for the on-premises setup. And we had to make specific changes, both in terms of modernizing our applications and also changes that are related to the whole software development lifecycle when we chose to adopt Kubernetes. For example, making those releases much more frequently. And that affected the also the on-premises customer base, because some of the changes had to be done that affected also the on-premises offering that we had and required some changes on the on-premises customer side. And that's where it affected the points of contact that were talking to those customers that weren't informed early enough. And that caused pushback, that caused additional time to clarify all those scenarios to ensure that everyone is aligned. And that is why you would want to ensure that everyone is aligned early on before you start the implementation, but also continuously check and see that everyone is still on the same page and think that this would be the good choice for your case. And another example is if you have a dedicated team, not necessarily you, but for example, if you have an operations team that is currently administering your current way of deploying, of running applications, and you need to think about what they need to learn and if they have enough competence in order to take over the setup on Kubernetes. So, for instance, in one of the cases where I was involved, we had an operations team that was coming purely from Windows ecosystem, and Kubernetes has a significant part of it being Linux. So you would need to understand how Linux operating system works, how you need to harden it, to secure it, how do you need to operate it, and if things go wrong, how do you debug it, how do you fix it on the operational side. So that would require for that operations team to use some time to get that competence. So this is something that is also an essential part of the zero stage, to have that communication, the dialogue, start testing it out, experimenting with it and failing and seeing if this is still the good option or not. And of course, doing the change for the right reason and not to just follow the trend, whatever that trend may be. And while we are talking about organization readiness, I think it's also very important to mention our dear developers. And developers, if we look at many conferences these days, a significant part of the agenda is about reducing cognitive load on the developers. And when we are introducing a new platform that, like Kubernetes in this case, this may have some changes in terms of software development lifecycle and in terms of daily routines, also for developers. And that's where it also is important to consider how you can reduce that cognitive load on the developers as well when implementing managed Kubernetes service. In most cases, developers do love being in their comfort zone and working on developing the applications and bringing value to those applications. And if we just throw Kubernetes and containers onto them, they, as you have seen on the picture earlier in this presentation, they may suddenly need to learn the whole, a big part of cloud native ecosystem, a bunch of new tools. If we were to give them some of that responsibility for understanding Kubernetes, and that can become pretty challenging, and that can have a pushback effect as well, because this may not necessarily be part of their job. So here it is important to think about how these adoption of managed Kubernetes service will affect developers. How much will they need to take responsibility for, and how you can abstract that complexity from them. And what I wanted to show you here is, it's a bit blurry, but this is, I think this is enough to kind of understand. This is a recording that was taken from one of the test clusters we had early in our adoption journey in one of the projects. And as you can see here, there are a lot of pods that are in the crash loop backoff, in the terminating, in the evicted state. And the reason for that was that there were no automatic checks and policies in place that would ensure that the configuration of the applications that were deployed to our Kubernetes clusters was correct. And that responsibility was given to developers, which did not know all the details of how Kubernetes works. And at some point, they had to look into creating those deployment templates for Kubernetes themselves. And if you don't have that experience from before, there are a lot of bits and pieces that you need to remember about, and that can create a lot of complexity, frustration, and chaotic situations like this. And that was many years ago, and from that time, I still like to bring up this example to illustrate that it is important both to abstract as much complexity as possible from the developers, but also have a dialogue with them, help them understand what they need to take responsibility of and how they can learn that. But even a more important part is to have those checks and governance in place to ensure that invalid or misconfigured changes will be blocked before they ever reach any clusters, because then you also help developers or help the consumers of your services to avoid making any breaking changes, and at the same time you avoid kind of needing to clean it up yourself afterwards. So looking into which tools you could use, which policies you can have in place would help you benefit a lot in the long run. So when it comes to thinking about developers and consumers of your Kubernetes clusters, it's important to think about how you may abstract that complexity away by having some blueprint templates in place that already have those best practices. For example, for when you're writing deployment manifests, having those best practices baked into a specific template so that developers don't need to think about it can already be helpful. If you have, if in many cases it would be beneficial also to look into creating an internal developer platform, and CNCF has recently released a white paper on that, on building platforms and what value it may bring. And that may be the very suitable use case for you as well, where you build a platform that kind of abstracts the whole configuration and creation of Kubernetes specific resources, and the developers may be just working with the UI or integrating directly with the user interface and just providing the configuration they need for their applications to run successfully. And then the backend logic takes the best practices and generates what is needed in the background, so they don't need to think about that at all. But having some way to abstract that complexity and make it easier for others to get those applications out in the Kubernetes clusters is also something that is worth thinking about early on as part of the day zero phase as well. And what I have seen and others benefit from, both when it comes to resources that where to take over and work with operating those Kubernetes clusters, and the platform that we have built, the internal developer platform that we have built for those clusters, and also for the developers who needed to understand how to run their applications on Kubernetes and in containers. Theory is good, but what I have seen being a huge benefit and value is having those hands-on workshops where you learn by doing, by going through concrete scenarios together and having that live walkthrough, even failing during that workshops and trying to troubleshoot and figure out a solution together. That's when you would learn, you would learn best. And starting with that knowledge building early on is also important. And as I mentioned, automated checks, having like Open Policy Agent with Gatekeeper, which are the most known tools in the CNCF ecosystem that have that where cloud providers have also offerings that are built on top of that, like Azure Policy, for instance, that uses that in the background. Integrating and enabling those checks to ensure that the best practices are enabled, and whatever violates those practices will be blocked before it reaches the clusters, is something that that can spare you a lot of time and is worth looking into and getting in place early on. And now we are getting closer also to another important aspect of adopting managed Kubernetes service, which is thinking about how you will be deploying your applications to the clusters. And when it comes to Kubernetes, what we hear a lot about is something called GitOps. And this is a golden standard, you can say, but this is the best practice when it comes to deploying applications to Kubernetes, where you have a declarative approach and repositories with the configuration that you want, that you need for your applications to run in the clusters, and then the clusters will be pulling that data, pulling that configuration, and doing changes themselves for you, and ensuring that there are no manual changes happening in those clusters or to the applications that are running in Kubernetes. So it always is consistent with what you define in your source code. So this is also a mindset and a collection of tools that you can integrate in order to kind of really take your deployment of the apps to Kubernetes to the next level. But there are a few points, a few factors that need to be in place to ensure that you are ready to do that. That also affects the state that your applications are in. You would need to think about if the teams are ready to have those quick releases, and if the development processes are in place where you have the fully automated lifecycle, from building your applications to running the necessary tests to running the security scans and checks, and also having the observability in place, the monitoring to ensure that you can detect any misconfigurations or any potential insecure or any other potential problems that may be in the new changes that you add to the applications. And in one of the cases, we had teams that didn't have that fully automated test suite in place for their apps, and they were not ready to release the version of their applications as quickly as possible. So we required a bit of the time to make those teams ready, fully ready to embrace the frequent releases and also GitOps processes that we were implementing. So this basically means that you can mature over time. If you see that you are not fully ready to embrace GitOps just yet, you may either need to think on how you could do that, and if you're required to make any additional changes as part of the day zero phase, or if you would like to first use other tools for deploying your applications to Kubernetes and then transition over to GitOps when everything is ready and you are fully mature for that. So this is also something that you would think about during the day zero phase. Another aspect that is very relevant these days is the cost aspect, and also how efficiently, how sustainably you are running your workloads in Kubernetes. And I'm not sure I'm going to take the chance, since we're in the live stream, that is a bit different when I can see my audience. I typically ask, like, throw the quiz question out there. But I will just try to say it straight away. If we were to think how much compute resources are actually underutilized, so they're just idle without doing anything in the Kubernetes clusters. There was a report recently that has been released by Cast AI, which is a cost management tool, where they discovered they have hundreds of clients that have integrated their tool in Kubernetes, and they could use that data to see how much of their resources that their customers have in Kubernetes clusters are underutilized. And what they have discovered is that it is almost 40% of compute resources that were just idle and not being used. And this does incur both costs and it is not running efficiently. So you are having more resources than you actually need. So this is the wasted resources that is not very sustainable, especially if you are not fully running on a renewable energy. And this is something that is totally worth thinking about and continuously adjusting also when you get your applications out there and monitor them over time with specific tools that would give you a full picture and help you make those adjustments to ensure that at all times you are utilizing the resources that you have in those Kubernetes clusters to their max potential, and at the same time are running cost-efficient workloads. And there was a report from Cloud Native Computing Foundation last year where they also discovered that 68% of respondents have experienced cost increase in terms of running their workloads on Kubernetes. And in these days, especially with economical changes and worries, cost have been one of the most important factors that companies and organizations are looking into. So thinking about that way of having the conscious cluster configuration is something that is also worth planning for as part of the day zero phase. Some of the examples that you may consider here is what types of virtual machines, what types of nodes you would need for your applications to run successfully and at the same time use the maximum amount of resources that those nodes have. How much CPU, how much memory would you need? Which regions are you going to deploy your Kubernetes clusters to? Because the different regions have different prices, but also they may be running on different energy sources. Some run on fully renewable sources, like, for instance, the regions here in Norway, but there are also regions that have more challenges in terms of being able to run on renewable energy sources. So you may need to consider what would be the most optimal choice for you. Thinking about scaling your applications, what kind of behavior your applications have, and what factors affect when you need to scale your application. In most cases, default metrics may not be enough, and that's where event-driven scaling comes into picture, like Kida, one of the open source tools that is very well known and very widely adopted, where you can define, it has tens of different scalars that you could integrate and enable for your applications that would have a specific type of metrics that you could use to ensure that you granularly define how your applications will scale and when they can scale out, and when can they even scale to zero if the application is not receiving any requests. And Kida, for example, released recently a carbon aware operator, which is also a very, very exciting functionality, where it monitors when the energy is dirtier and when it's cleaner, and then it does more, or it scales out an application when the energy is greener to run as much workloads as possible, and then it scales down when the energy is dirtier. And for example, if you have a use case where you need to train your machine learning models in a test environment, this can be a great way to optimize when you actually perform that training, and then you scale to zero when you don't need that, and then when it's also less sustainable. Once again, looking into policy management tools that you could use to also ensure that you have some of these checks in place. For example, which regions are allowed to be used for deployment of Kubernetes clusters. And there are other rules that you can integrate, is also very beneficial. And tools like OpenCost, KubeCost, like Cast AI that I mentioned, can also be very helpful and focus mostly on your clusters, on Kubernetes clusters, specifically on applications running on those clusters. They can monitor the trend over time, show the cost trend based on the namespaces or based on a specific Kubernetes object, Kubernetes resource, or Kubernetes object like service, which can give you a pretty granular picture of how cost efficient and resource efficient your clusters are. And those tools can even measure cluster efficiency and come with concrete recommendations. Like, I have seen that these node type has been quite underutilized, so you may consider switching to a different family type in this specific cluster. So those recommendations can even be like a helpful assistance for you in making more informed choices during cluster optimization. And in Norway, we have a word that is called dugnad. This is once a year when everyone goes out and starts cleaning their gardens and surroundings around the house, cleaning up that wasted, unused waste, and to ensure that everything is nice and shiny and looks very good. And that's something that I feel like a very good association in this case as well. Performing that continuous dugnad, performing that cleanup, where you go check your clusters, verify that if this application hasn't been receiving any traffic recently, is it actually in use? If not, why do we let it be a zombie workload? Let's just clean it up and bring it down so that it does not waste resources, so that we can get more room for new applications, or choose a different type of nodes, a different type of virtual machines to run as part of the Kubernetes clusters. So continuously performing that dugnad will also help you to reduce cost, and maybe some of that reduced cost you may also use to invest in some different important enhancements in your applications or in the clusters. And this is one of the tools that I also wanted to highlight, which is called Cloud Carbon Footprint, where you could see the energy, the energies, how renewable, how good, how clean the energy is, based on different cloud service providers and based on different regions. So this is an example of the regions that are offered by Azure, by Microsoft Azure. So here you may see, for example, which regions are more sustainable and which are less sustainable, like the dark red ones on the right-hand side here. And if you don't want to install that tool, they have also created a heat maps. I will share all the resources in the GitHub repo that you could take a further look at afterwards, where you could also see this same information as well, which can also help you understand and make a better choice in terms of what regions you would like to deploy your Kubernetes clusters to, for example. And while we are still talking about cost, I mentioned that also depending on what region or depending on what operating system you choose, you can see the difference in terms of cost as well. So here is an example of the same family type of virtual machines. Once again in Azure, since I'm working mostly with it, so that was the easiest for me to retrieve this data. Here you could see the Linux, the virtual machines that are using Linux operating system, and down here you may see the same family type for virtual machines, but using Windows operating system. And as you can see, the difference in terms of pricing can sometimes be more than double in some cases. Like the first one here was $78 for Linux and $145 for Windows. So you can imagine that there is also a good one of the good motivational factors to why in some cases you would like to consider if your application can be running on Linux, for example. And here is another example in terms of the region. So here I took a comparison last year for the same virtual machine type in different regions. So last year, B2S virtual machine type had 289 kroners for North Europe, and then over 300 kroners for West Europe, and then almost 340 kroners for Norway East region. And if we take a look at the North Europe, for example, 289, and look at this year's numbers, you could see that it has increased to 321. So as you know, there have been quite many places price increases also due to the macroeconomic situation. And those increases have been different in different countries. So thinking about where you can deploy your resources to, that is both cost efficient and, for instance, compliant with privacy laws, is also something that is worth considering and assessing as part of the day zero stage. And this is also an example taken from KubeCost tool, where you could see that it provides some information in terms of the efficiency of your Kubernetes clusters and how much CPU, for example, and RAM has been requested and how much of it is actually used. So you could see if you could make some adjustments. And it does come with recommendations that can also help you optimize the workloads that you are running in the clusters, both from the cost and sustainability and resource utilization perspective. So definitely check some of those tools out. I think we're getting to the last domain that I wanted to bring up today, and that is security. And security has been for a long time underestimated in terms of Kubernetes. And if you think about it, Kubernetes in its nature was not necessarily created with all the security proper strict security configurations by default. It had different goals in the first place. And security was something that the consumers of Kubernetes clusters are responsible to kind of integrate to make it properly hardened and fully ready for production. And this also does apply for managed Kubernetes service offerings as well. Cloud service providers do secure quite a lot, but there are also default configurations that your clusters may get that differ significantly depending on which cloud service provider you choose. So understanding what you need to check and what you need to improve and to harden further is something that is also worth thinking about early on. Typically, one more quiz question that I ask the audience, but I may just skip that this time since I can't see you. But if you look at these numbers, there may be many things these numbers may mean. But what is it actually? What it actually represents? Sorry, Ilham? Yeah?
Yes, I just want to say that even though we can't see the actual audience, right? But we can still pose the question here, wait for maybe, 10, 15 seconds and look at the chat, and that way
Do we
we may
have time for
interact with
that?
the audience.
If
I
we
mean, yeah,
do, then
we can give this question. I mean, please give your question, and then I will monitor the chat and I will bring the answers if there are any. If there is no answers, then you are going to unpack the answer for us.
okay. So then the question is, what do you think these numbers represent? What are they? No cheating. So don't Google it.
And I also post the question on our chat for everyone. So let's see.
So you can also join, Ilhan, actually. So you can also come with your suggestions, unless you know what it actually represents. If you know the answer, then that would not be fair.
I don't want to spoil the, surprise.
Oh.
So we get the first answer here. Thank you everyone who is putting. So first came from, and I'm going to bring that in the studio. It's from Nico saying number of my failed tries to learn Kubernetes per month. So it's a
Whoa.
subjective, but let's see. So then we have another response. Thank you, Nikos, for putting that. So another response come here from Gabor, and thank you, Gabor, for being part in the chat, taking active uh, communication there. So he said it's a vulnerabilities.
Mm. That's a very interesting. That's actually quite being brought up quite often. It's actually not that bad in terms of vulnerabilities. So that's not quite that, but that was a very good suggestion, though.
Mm-hmm. So any other suggestions? We are closing this. We have 5 seconds.
Oof.
5, 4, 3, 2, 1, done. So go
Ooh.
ahead.
All right. So that was also not your attempts to learn Kubernetes, Nikos. I don't think it was that bad as you may state, but what those numbers actually represent is the number of exposed, publicly available Kubernetes API servers and services that may be running on those clusters, like, for instance, Kubernetes dashboard. So most part of these numbers represent the API server, which acts as a middleman and takes the requests for example, provisioning a specific resource on a Kubernetes cluster, and then it communicates with the rest of the Kubernetes control plane to actually execute those changes. So you may think that API server is quite a sensitive component of a Kubernetes cluster, and it actually is. And you can see that in many cases it is publicly available. It does not mean that you can execute you can make it execute any commands on the cluster, but you may call it. So it may be available through a fully qualified domain name that you could call, and then it can give you a reply back, like, for instance, a 401 error. But this is an unnecessary threat vector that you may have that is publicly available for attackers to work with and see if they can get in, if they can get further and maybe trick that into executing some commands. And this is something that you may not want to be available for anyone. And in some cases, API server may be available, publicly accessible or callable by default. For example, if we think about AKS, if you do not configure IP ranges, limiting to IP ranges or creating a private cluster, its API server will be accessible by default. So you could call it and you would get an unauthenticated error bag, but this is still a vector that you could further work with. So this is a quite a cool website out there. I will actually take a quick minute and show you this one. This is a website developed by Shadow Server, which is one of the security companies that is working also with kind of security scanning and trying to locate the exposed Kubernetes clusters. So here you could see live how many Kubernetes clusters out there are currently publicly available, and you could filter based on if you want to see for the last week, month, or a year, or any other date range. And then you could also choose by the country. So this is currently the total in the whole world. So 25th of July, it was yesterday. As you can see, 295,130 clusters that have some exposed resources. So if we filter, for instance, on Norway, where I am based, we can see that it was 31. So that's not as bad as I expected, but still, there are still 31 clusters out there that you could call or access in some way. So the link will also be available in the GitHub repo. If you're curious, just you're welcome to check it out and play around with it as well. Let's see. So this is, yeah.
Yeah, and just one thing, we have a question from one of the viewer, Gabor. Thank you for putting that question. So he has like interesting question saying that, do you know the reason of jump in June and the drop in October months when we look at those numbers?
Let's take a look. Yeah, you mean when we looked at the whole... Oh, in October. You mean like on... Sorry. Let's see. You meant on the general numbers, probably.
Yes, on slide. It was for 2022.
Yeah, those were... I think this is not the same laboratory or the same company that was doing the scans. So I think the first... there were 3 different companies that have been doing the scans. So they have been using different tools for that. So this may also be the reason for why we are seeing different numbers, because they may be using the different logic for what they're acquiring to detect the amount of publicly accessible clusters. So this is probably the reason for that. And I think that some of the tools were developed further, like since May 2022, where we also saw like that there was 900,000. But in this case, I think they were also acquiring not just for the API server, but also for different resources like Kubernetes dashboard or some, for instance, like KubeCost dashboard examples that were deployed, that were applications that are supposed to be internal for internal usage, for internal operation of Kubernetes clusters, but they were not kind of secured or isolated properly, so they were able to query those. So this was also the reason why this amount may be a bit larger than the others. But if you can see from the Shadow server, it's the last one. Mm-hmm. The last one here was done by Shadow server, the ones who own that website I showed you. So as you saw, from October 2022 to yesterday, it has also decreased from almost 50% to 200 something. And another reason may also be that clusters were either secured and hardened or removed for example, which also may be the reason for why you see the difference in the numbers. Extreme numbers. When I saw 900,000 for the first time, I was shocked, to be honest. I
Yeah.
didn't expect to see such a huge number, actually. So that's and that's why I also say that security has been underestimated for a while when it comes to Kubernetes, and I see the great difference now these days that we are talking more about it. But I need to say that it's one of the important domains that is totally worth thinking about early on, because I have also been in a project where we started thinking about security later. And we had customers coming back and asking proof because we got the services, some of the services up and running in production, and some of the customers started using them. And then they started coming back and saying, are you compliant with OWASP top 10 for Kubernetes? Are you compliant with OWASP top 10 for containers? Are you compliant with the hardening guide from NSA for Kubernetes? And understanding that you may need to do some changes and even some refactoring to be fully compliant when you are already out there, and running the services is not something you want to end up doing, and some changes may not be necessarily that easy to do while you have the applications up and running, so you may need to fully recreate your cluster setup, which may also affect other dependent components. So it's totally worth thinking about early on in the process. Let's see. I just need to ensure that. Am I over time? I'm over time.
Yeah, we are
Oh,
approaching
yeah.
that mark. Yes. So if you
Oh,
want,
I'm
you
so
can a little
sorry.
bit fast forward, but I mean, people are watching, so it's very interesting session. Thank you for
Okay.
open question as well. We took a little bit of time there to get the audience responses, but it's all goes good. So please continue.
Okay, thank you. Then I will use a few more extra minutes. So sorry about that, but thank you if you're staying alone. I don't have that much left to talk about, but still, I find that security is something I can talk a lot about, and that's quite an extensive topic. So quickly, if on the also on the Cloud Native Computing Foundation website, in the Kubernetes documentation, you may find something that they call a C4 for security, which represents the layered approach of how you would think about Kubernetes security in context of cloud native security in general. So it is also a layered approach. It's not only about securing the clusters themselves, but also securing the containers that your applications are packaged in, the application code itself, and also looking into other dependent components that your clusters will need to use that are being offered by the cloud provider, and if there is any further hardening and securing that you need to do there. And if one of these layers is not secure or is vulnerable, then this affects the whole security of your setup and also your applications. So thinking about the layered approach and doing that step by step improvements is important. And when we think about containers, one of the highlights that I want to mention is also consider running your applications in containers as a non-root user. And there are great changes happening in that space already, and more base image providers are offering a version of the image that does not have a root user by default. So you would need to consider that when you are choosing the base images for your applications to package them into containers, if you could use an image that does not use a root user, because root user has elevated privileges. If someone gets access to that application, will manage to break into it, they may potentially escape out of that container and do some malicious actions that will affect also other applications that or the whole cluster that the application may be running in. So this is there are more improvements happening in that space. Like for example, Nginx, as an example, base image has now an unprivileged version of it, and the same is happening for ASP.NET Core. For example, they have now images that are slimmer, and are also rootless. So it's worth looking into your options on that part as well. And even though DevSecOps is kind of a hype word these days, to me, this means kind of the importance of how you approach security in your own projects and with your customers, and also yourself, looking into that continuous communication and collaboration. If you have security folks in the team, getting them up to speed, making them understand what containers and orchestration with Kubernetes is, which way you are going, and how they can help you to ensure that it's properly secured, is something that you would also benefit from, so that it's not only you working on those changes. And this, you can also check these slides afterwards. I think this is a great illustration of how you do that. So integrating specific security controls at every stage of software development life cycle, and also when it's up and running in those clusters, how do you ensure that both the clusters and the application is running in a secure manner? And once again, governance and policy management tools can also help you with integrating specific rules for that. And there is a bunch of different frameworks that include the industry best practices that you could take a look at and reference. And like OWASP, they have even I look at those even like cheat sheets, because they also provide you concrete examples. Like, this is the insecure configuration. This is how you would use, for example, security contexts in Kubernetes to ensure that the application is not allowed to elevate user permissions, or is not allowed to run with the root user. So you could actually get concrete solutions from some of these documents on how to implement a specific security control. So do check that out as well. And last point, which I will try to keep short, is the story of day 2 operations, or being prepared, or taking into consideration that things may fail. And we hear or think of cloud service providers as they are investing a lot of money and resources to ensure that all their services are available at all times, and everything is highly available and secure and protected where they have the responsibility. But still, no one is perfect, and there may be things happening that may be out of control, even for the cloud service providers. So here is an example of when last year the Amazon, in one of their US regions, it had a power outage, which caused some of the quite big and popular services to be down in terms of a few hours. And the year before that, they also had the similar situation where one of the availability zones in the US region was also down, that caused outages for a batch of services. So thinking about that, being prepared for that, is something that we shouldn't take for granted. And the same example happened with Azure last year, where they had a faulty update that was deployed to the Linux nodes that were using Ubuntu 18.04, and it caused outage for probably most for all of the regions, more or less. And it took quite some time to get back to speed, and to kind of to get that fix rolled out for everyone. So it took quite a long time. And thinking about the disaster recovery, the business continuity planning, and which actions you can take, and how much time it takes for your system to get up and running, for your clusters to get up and running once something happens, like a disaster, like an outage like that, is also worth thinking about early on. A few bullet points to think in this case is to have that observability in place, to look into the tools that you could utilize that cloud service providers may already have in place for you to ensure that you can detect potential issues early on and get alerted in case things go wrong. Upgrade strategy, understanding how to you can upgrade those Kubernetes clusters and getting experience with that as well, and also thinking about that you need to continuously upgrade those clusters in order to still be compliant with the regulations that cloud service providers may have. So you can't in most cases be on a single version of Kubernetes for many years. So you would need to ensure that you're following that rules that a cloud service provider has, or like AKS actually did now that they have released the long-term support version for their managed Kubernetes service offering, and looking into if you could utilize that, or if the cloud service provider of your choice offers something like this, is totally a due diligence action that you should take in as part of the day zero phase. And with help of chaos engineering tools, for instance, you could even simulate some of the disaster situations or outage situations for the region or for the cluster or for the nodes, for the specific nodes, or even for DNS in some cases, depending on which tool you choose, which will kind of help you get that more close to real life experience and test both your platform setup, your infrastructure as code, how much time it takes, and how your resources that are working with Kubernetes clusters and the applications that are running there will react. So involving the necessary resources and looking into these tools early on and how you could utilize them will benefit you also in the case things will go wrong. Yes, I've run a lot over time, but summing it up, of course, looking into documentation like well-architected framework or enterprise-grade Kubernetes clusters that cloud service providers currently offer is something that I would definitely recommend to look into. And also looking in some of those frameworks that I mentioned for security that will give you some pinpoints in terms of what security controls you would need to get in place. And also starting early with getting that hands-on and involving those who will be working with those Kubernetes clusters is totally important. But even more important is the collaboration culture and getting that communication and alignment early on to ensure that you will not be the only one that may be putting out fires, but you will get a proper setup in place from the start is something I think is very important as part of the day zero. And thinking about how your Kubernetes clusters will look like before the implementation will help you spare time and get out there to production quicker. Yes, then I think I am done. So if you would like to check some of the additional resources and more details, I have all those links available in the GitHub repo, and this is the QR code on the left-hand side here for that one. But if you have any questions, both now or afterwards, don't hesitate to reach out to me on one of the social medias where I see I need to change this icon since it's probably not relevant anymore. So yeah, thank you so much for your
Thank
time.
you. Yeah, thank you, Chris. Actually, it was very engaging, interesting presentation, and thank you for all these pictures and emojis, and to make sure that the presentation goes smooth. So I think everybody after watching this session, you would have a good understanding about the Day Zero Survival Pack for managed Kubernetes service. And if you don't, and you still have some questions, then here's a QR code, that Chris actually provided for us. So feel free to scan that or tweet and get connected with her. All right. This is your chance to give your last questions or whatever burning question you had in your mind while watching this interesting session. So I will watch the chat for another couple of maybe 10-15 seconds. We have thank you from Nikos, thank you from Gabor, thank you guys
Hmm,
actually taking uh,
thank you.
time and space, so to speak, answer these questions and having some chat discussion going on there. It was really awesome. And as you see, these are thanks a million here from
Thank
Nikos,
you.
and we have also thank you for a cool presentation from Gabor, and it was a pleasure to watch and listen again. All right, that said, thank you everyone in Cloud Launch and Learn for being a part of this great session. And here are the links for you so you can follow up on this. And back to you, Chris. So, any last minute announcements or anything that you want to bring and speak about?
I just want to say thank you for also for engaging and for asking questions and for the comments as well. I appreciate that, and thank you for staying with me for a bit longer than expected. So don't hesitate to reach out.
Yeah, thank you very much again, Chris. Thank you, everyone in the studio, Cloud Launch and Learn. Please check our next week's session in our website, and I hope we can see you all. So, have a good day, rest of the day. We are ending the session here. Bye.
Thank you. Bye.